Hey everyone, welcome to my channel. In this video, let's solve another interesting coding problem called Dungeon Game. So first we'll understand what this game is all about, then we'll see how we can solve the problem, and finally we'll look at the code implementation. Let's dive into the problem now. So here in this game, there is a dungeon. It's an m cross n grid consisting of positive and negative integers. I'll come to that later. Okay, so there's a queen Q that has been captured by some demons and she's been placed in this bottom right corner cell. So each of these is a cell or a room that you can consider. So this queen has been placed here by some demons. We have a knight, a valiant knight who can save the queen. So he can enter this dungeon from this top left cell. So whenever a knight enters a particular room or a cell, so if the value is negative, that means that there's a demon that can reduce the health of the knight. If the value is positive, that means there are some magical orbs that increase the health of the knight. Now, the knight's objective is to save the queen by reaching this bottom right corner cell with a health that is at least equal to 1. Minimum of 1. Now, our objective is to find the minimum health that knight requires in order to save the queen. So, what do I mean by that? Let's take an example. Say initially the knight's health was, let's say it was plus 5. So the knight enters this particular cell here. So his health, once he enters this room, it will reduce by 2. So his health would be 3. Then either he can move down or towards his right. So that's the direction the knight can move, only to the right or towards the bottom. So when he moves to the right and enters this cell, so his health here would be 3. Now when we subtract this minus 3, his health is 0 and he will die. So when his initial health is 5, he cannot save the queen. Let's try another possibility. Let's increase it by 1. So let's assume that his initial health is 6. Now he enters the cell. So it reduces by 2. So his health would be 4. Now let's again assume that he is moving to the right. So he'll come here. 4 minus 3 is 1. His health is 1. Then let's assume that he is moving to the right again. He'll come here. This is 3 plus 1. It will be 4. He'll come down and his health would be 4 plus 1, 5. Now again he'll come here. His health is 5 minus 5, it is 0. So that means again he cannot save the queen. So when he enters this bottom right corner cell, his health should be at least value of 1. So by now we understand that his health, the minimum health he requires is basically 7. So when his health is 7, so he enters the cell, the value here would be 5. Then he comes here, 5 minus 3 is 2. Then he'll come here, 2 plus 3 is 5, 5 plus 1 is 6, 6 minus 5 is 1. So the health is 1 here and he has reached this bottom right corner cell, so he can save the queen. So our objective is basically to find the minimum health that the knight requires to save the queen. So how do we solve this problem? Okay, since the knight can either move down or towards his right, there are multiple ways the knight can choose to reach the queen. If the knight's initial health was infinity, then the knight can choose this path or this path or this path or this path or any of these paths to save the queen. But our objective is to find the minimum health that the knight requires in order to enter the dungeon and save the queen. Okay, so the minimum health required by the knight at any particular cell depends on the minimum health required by the knight at the adjacent cells. So if we can somehow compute the minimum health required by the knight at this cell and this cell, then we can choose the least among the two and find the minimum health required by the knight here. Now, the minimum health required by the knight at this cell depends on the minimum health required by the knight at this cell and this cell. So if we can compute this, then we can again choose the least among the two and find the minimum health required by the knight here. So we can continue this process and until we reach the last cell. So the minimum health required by the knight here, since the value is minus 5, the knight requires at least a health of 6. So 6 minus 5 is 1. So the knight survives and he also saves the queen. So this is the base case. So once we know the minimum health required by the knight here, then we can find the minimum health required by the knight here and here. And we can work backwards and find the minimum health required by the knight here. So this problem can be solved using recursion. Now we can notice that there are certain cells that are being revisited multiple times. If you take this cell, it's being visited from the top, as well as from the left. Similarly, this cell is being visited from the top as well as from the left. So once we compute the minimum health required by the knight at any particular cell, we can store that value, that is memoization. So, and use it for further recursive calls. So this problem can be solved using recursion and memoization, that is top-down dynamic programming. Or another way is to solve using bottom-up dynamic programming. That is the tabular approach from this cell here. So we will solve this problem using bottom-up dynamic programming. But this can also be solved using recursion. So let's see how we can do that. Okay. So according to dynamic programming, if we can split the given problem into smaller subproblems such that if we find the optimal solution for the subproblem, then we can find the optimal solution for the bigger problem. So here the smallest subproblem that we can think of is a dungeon consisting of single cell. So if the dungeon had only one cell with the value of -5 and the queen is placed here, so the minimum health the knight requires in order to enter this cell should be at least 1 greater than this value here. So that is 6. On the other hand, if the value was positive, if the value was say +4, then the minimum health the knight requires in order to enter this cell is just 1. If the knight has a health of at least 1, he is able to enter the cell. His health will be increased by whatever value is there on that cell, and he will be able to save the queen. So if the value is negative, then he should have a health at least 1 greater than this negative value. Okay. So here I have a DP table. The DP size is 1 greater than this dungeon. So this is m cross n and this is m plus 1 cross n plus 1. And the last row and the last column is filled with infinity. So you will understand the reason in just a moment. Okay, so we have computed the minimum health required by the knight in order to enter this cell, so which is equal to 6. Now let's compute the minimum health required by the knight in order to enter this cell. Okay, so the knight from here can either go down or towards his right. Now he won't be able to go down because this is infinity, so he will try to go towards the right. Okay, the minimum health the knight requires in order to enter this cell is 6. So the minimum health the knight should have in this cell should be at least 6. Now if the knight is somehow able to enter this cell, then his health will be increased by 30, right? It will be increased by 30. So the minimum health the knight requires to enter this cell is just 1. So 1 plus 30 is 31, and this value is much greater than the required minimum health of 6. So the minimum health the knight requires in order to enter this cell from top or left is just 1. If you did not understand this, you will be able to understand as we proceed. Okay, let's compute the minimum health required by the knight here. Okay, the knight can either go to the right or to the bottom from this cell. Now the minimum health the knight requires in order to enter this cell is what we have to calculate. Okay, so in order to enter this cell, the minimum health the knight requires is 1, and if the knight is somehow able to enter this cell from the top, then his health is increased by 10, isn't it? Now the minimum health the knight requires in order to enter this cell is just 1 again. So if the health of the knight is 1, so he will enter the cell, his health will be increased by 1, so by 10 it will be 11, and this 11 is much greater than the required minimum of 1. So he is able to save the queen. So the required minimum health in this cell is 1. Okay, now let's fill the cell value here, the DP table value. Okay, the health value here is not the health, the whatever magical odds or whatever, that value here is 1, and the minimum health required by the knight to enter this cell, the one at the bottom, is 6. Now if the knight is somehow able to enter this cell, he has to go down. Now the minimum health required by the knight to enter this cell is 6, and he has a power up of just 1 in this cell. If the knight's health was say x when he entered this cell, then x plus 1 should add up to this value here. Otherwise he won't be able to go down and save the queen, right? So the minimum health the knight requires in order to enter this cell should be at least 5. So if the value is at least 5, he is able to enter this cell from here. So the minimum health required by the knight to enter this cell should be at least 5. Okay. Now let's compute the minimum health required by the knight here. So this value here is minus 10. Now in order to survive, the knight requires at least a health that is 1 greater than this. That is, should be 1 greater than this value. So this is 11. So if the knight has a health of at least 11, he is able to enter this cell and he can survive in that cell. Now the minimum between these two is 1. So he'll try to go down this path. So when he enters this cell with a value of 11, then his health will be reduced from 11 minus 10 is equal to 1. So he is able to go down this route and he will be able to save the queen. So the minimum health the knight requires in order to enter this cell either from the top or from the left is at least 11. I'll suggest you to pause for a moment and think this. It's actually simple, but I'll suggest you to just try to think and then understand what's happening here. Okay. Now let's try to fill this value here. Okay. The minimum health the knight requires in this cell. So here the value is negative. So in order to enter this cell, the minimum health the knight requires to enter should be at least 1 greater than this value. So minus 5 modulus of this plus 1. So it should be at least 6, isn't it, for the knight to enter this cell. Now the knight will try to again choose the path with the minimum health required. So the minimum among these two is 1. Now if the knight is somehow able to enter this cell and survive, so the minimum required is 6. 6 minus 5 is 1. So if he is somehow able to enter this cell with a value of 1, then he will be able to go down this path and save the queen. So the minimum health required to enter this cell is 1 greater than this negative value here. So it's equal to 6. Okay, let's fill this value now. The minimum among these two is 5. Now if the knight is somehow able to enter this cell, in order to save the queen, he should have a health of at least 5 to enter this cell. So when the knight enters this cell, his health will be increased by 3. So x plus 3 is what if the knight had a health of x, then it will be increased by 3. Now this value should add up to at least 5 in order to save the queen, right? So the minimum health required by the knight to enter this cell should be at least equal to 2. To enter this cell, the knight requires just a health of 1 to enter. But in order to save the queen, the knight requires at least a health of 2. So 2 plus 3 will add up to 5 and he is able to go down and then save the queen. Okay. Now let's compute the minimum health required by the knight here. So the cell value here is minus 3 and the minimum between these two is 2, right? Now in order to enter this cell from here, the knight has to have a health of at least equal to 2. In order to enter this cell, the knight should have a health at least one greater than this. Now if the knight has a health of x, then x plus minus 3 should add up to this value here, the minimum between these two, 2. Only in that case he is able to save the queen, isn't it? So x should be equal to 5. So if the knight has a health of 5, he is able to enter this cell and he is also able to save the queen. Okay, let's compute the value here. So the minimum between these two is 5. Okay. Now the knight will choose to save the queen via this path. Okay. So in order to enter this cell, the knight requires a health of at least 1 greater than this, which is 3. But then in order to save the queen, he should have a health of at least 5. So x plus minus 2 should add up to 5. That is, the knight should have a health of at least equal to 7. So 7 minus 2 is 5, and he's able to take this route to save the queen. So this is how we'll be able to solve this dungeon game problem. So the minimum health required by the knight to enter this dungeon cell is found by this value here, which is 7, and he will be able to save the queen. Okay, I'll suggest you to rewatch this video if you did not follow. Also take some examples and try out. Okay, now let's look at the time and the space complexities. The time complexity is equal to the size of this table. So it is n plus 1 by n plus 1. Time complexity is into n plus 1. So the time complexity is basically big O of m times n. Also the space complexity is the same as the size of this table, and it is also equal to big O of m times n. Now let's look at the code implementation, and it will be more clear as we see the code. Thank you.
Okay, let's look at the code implementation in this section. So here we have a dungeon consisting of positive and negative integers. Like you know, the negative integers are demons that reduce the health of the knight, and positive integers are magical orbs that increase the health of the knight. So here we have a function called calculate min health. So this will do the actual work for us. So we are passing in the dungeon to this function. So let's look at this function. So in this function, firstly, we'll calculate the number of rows and store it in M, number of columns and store it in N. And we are creating a DP of size. It's an integer of size m plus 1 and n plus 1, integer array, two-dimensional array of size m plus 1 and n plus 1. Like I said, we will fill the last row and the last column with infinity. So infinity here is the maximum value that we can think of with integers. Okay, and this is the part where we are calculating the minimum health required by the knight in the last cell. So this is our base case. So here we are checking if the dungeon value is greater than 0, then the minimum health required by the knight to enter this cell is just 1. On the other hand, if the value is less than or equal to 0, that means we have to have a health that is at least 1 greater than the negative value. So we take the absolute value of the dungeon at that particular cell and add 1. So this is the minimum required in the last cell. So this is the same logic that we'll be applying for the other cells as well. So let's look at that. So again, here we are iterating through this dungeon from the last cell. We'll ignore the last cell m minus 1 and n minus 1 because we have already computed it here. Now this is the part where all the magic is done. So initially we'll calculate the minimum between the next cell, that is the next column. This is the next column and the next row. So calculate the minimum in the next column and the next row. And then what we do is we calculate the, we find the dungeon value at that particular cell. If the value is greater than or equal to 0, that means the minimum required by the knight. If the dungeon value is greater than or equal to 0, then there are two cases again. One is if the dungeon value itself is greater than the minimum required, the minimum that we calculated. If that is the case, then the minimum required by the knight to enter this particular cell is just 1. On the other hand, if the dungeon value is greater than 0, but then it's lesser than the minimum required, then we need to make up for the difference. So that is obtained by min minus dungeon of ij. So please refer the whiteboarding video. You will be able to understand this part. Um, okay. Now this is the case when the dungeon value is greater than or equal to 0. If the dungeon value itself is less than 0, then the minimum health required by the knight to enter this dungeon cell is the minimum that we calculated earlier between the next column and the next row, and the absolute value of the dungeon cell. The negative value, whatever we had, we add up that with the minimum, the absolute value. So uh, that's about it. And here I'm just printing this DP table, the computed DP table. Let's try to run this code. So this is the same example that we saw in the whiteboarding. So I'll run this. Okay, so these values here are basically infinities, so ignore them. Now this value first one here, this is the value that we computed at the first step. So the minimum health required by the knight to enter the cell is the absolute value of this plus 1. So this is the minimum required, and this is the base case. Now we work backwards and start filling all of these cells. So here the dungeon value itself is greater than 0, and the minimum health required by the knight here here is 6, and this dungeon value is greater than the minimum required, that is 6. So if the knight enters this dungeon cell with just a value of 1, then his health will be increased by 30 and he's able to save this queen. Let's try another example. So we can continue this process, and the minimum health required by the knight to enter this dungeon cell from the top left cell is equal to 7. Okay, let me run this example here. So the minimum required by the knight, minimum health required by the knight to enter this dungeon cell is 2. Let's walk through some of the cases. So here the value is -6, the last value. So the minimum health the knight requires now to enter this particular dungeon cell should be at least 1 greater than the absolute value of this. So that should be 7. So this is the value that we see here. Now, um, okay, so the value here is -3. The minimum health required by the knight should be at least 1 greater than this value. But the minimum health the knight requires now to enter this dungeon cell is 7. So in order to make up the difference, that is from -3, we should go to 7. So the minimum health required by the knight to enter this dungeon cell should be at least 10. So that is the value that we see here. So 10 minus 3 is 7, and then the knight will go from this cell to this cell. 7 minus 6 is 1, and he is able to save the queen. So likewise, we can fill all of these cells here, and the minimum health required by the knight is equal to 2. I hope this is clear. And I've already explained the time and the space complexities, which is equal to the size of this table, which is m times n, big of m times n. If you have learned something new in this video, please do hit the like button and also subscribe. Thank you for watching.